With today's Do Now, we're going to determine if the ordered pair negative 3, 10 is a solution to the inequality y is greater than negative x plus 7. So you want to remember that ordered pair is an x and a y. To determine if it's a solution, we're going to substitute in and see if it holds true for that inequality. So we got that negative. Now I substitute in for x, negative 3 plus 7. So we've got that double sign. Negative times a negative is a positive. So 10 is greater than 3 plus 7. 10 is greater than 10? No, it is not. So negative 310 is not a solution. Okay, it does not hold true for that inequality. You might be thinking, oh, but if it was equal, curious to say, this point would be on the line if we were to graph it. But it's not an equal to, so it's not a solution, which is why when we have that greater than, we're doing that dotted or dashed line, which shows us the points on the line are not actually a solution. Here, I just want to review a little bit of what a solution is and where we see them. So what does it mean to be a solution to a linear equation? It's a point that must be on the line. That's the only way something can be a solution to a linear equation. It has to be a point on the line. But when we have a linear inequality, there's far more options. A solution can be a point on and above the line. We see that with our greater than or equal to. It could be a point on and below the line, which we see with our less than or equal to inequality. It could be just above the line, so not the line itself, but just those points above it, like we saw with our do now, where we have that greater than inequality, or just below the line, so not including the line, but just underneath it. Just like we have these differences between our equations and inequalities, we also have differences with our solutions to systems of equations and systems of inequalities. With our system of equations, the solution is the point of intersection of the two lines, just that one point where they intersect. But with a system of inequalities, where there's more solutions, right? We have that shading to show all the points that are off the line when we graph our linear inequalities. There's going to be more solutions to a system of inequalities. So when we graph multiple inequalities, the solution to that system is where they overlap. So we have this blue, this darker purple with an inequality, this lighter purple pink with an inequality, and the solution to that system is this area here in the middle. And when we graph by hand, we're going to put in a big S for solution set. Here on page 39, we're going to graph our system of linear inequalities, where our first step is we're going to make sure our inequalities are in slope-intercept form, and then we are going to graph one, do our test point for our shading, graph the other one, do our test point for our shading, and then identify the solution set. So let's get started here. So first equation I'm looking at, negative 2y is greater than 4x minus 8. It's not in slope-intercept form. So we're going to divide both sides by negative 2. Divide by negative 2. Oh my gosh, we divided both sides by a negative. Flip that inequality. We had to flip or reverse that inequality because we divided both sides by a negative when solving. 4x divided by negative 2. Negative 2x, negative 8 divided by negative 2 is a positive 4. So there's a few things we want to identify here as we go to graph. One being our y-intercept, 4. The slope is negative 2, or as a fraction, negative 2 over 1, which tells me go down 2 spaces to the right 1 space. I also want to notice our inequality of less than tells me we're going to be a dotted dashed line here, and that since it's less than, we're going to shade below the line where the smaller y values are. So let's start at our y-intercept, 4. Our slope is negative 2, so we're going to go down 2 to the right 1. So I'm getting that nice negative slope, making sure I'm getting that nice straight line. Go back to my y-intercept and reverse the directions up 2 to the left 1. Okay. Now it's that dotted or that dashed line, so I'm going to make sure to pick up my pen every once in a while. So I'm following through with that, showing that the points on the line are not a solution to the inequality. Putting arrows at the end, and I'm going to label. Right, I'm kind of labeling off the coordinate plane a little bit because I have to shade. So I don't want to write my inequality and then shade right over it. So we're going to shade below the line, right, because it's less than. So my guess is that we're going to shade where the smaller y values are, all down here. But again, it's a new subject, so I'm going to model using a test point. We can use the ordered pair 0, 0, so we're going to. Because that point is below our line where I think I'm going to shade, I'm kind of hoping it'll work. That's my guess, is that when I substitute in, it'll be true and we will shade that way. So we substitute in, 0 is less than, 0 plus 4, 0 is less than 4, it's true. So we are going to shade where that test point is. Now remember, we have to go and graph another inequality, so I cannot scribble. I'm going to do a nice control shading, and I'm going to leave some space in between my lines of shading. I can always go back and make it darker. That was actually really beautiful controlled shading. If I have to say so myself, look, it's all like evenly spaced out. I don't know if I've ever done a better shading than that. But anyway, we'll continue on to the next one. Our next inequality, y is greater than or equal to negative x minus 5. It's in slope-intercept form, so we're ready to go and graph. We're going to take some key information. Our y-intercept is negative 5. Our slope is negative 1, which if I write as a fraction is negative 1 over 1, which tells me go down 1 space to the right 1 space. Okay. I can see from our inequality it's an equal to, so we're going to be doing a solid line because all those points on the line are going to be solutions. It's a greater than, so I'm thinking about shading above the line where those y values are greater on our y-axis. So we'll start graphing negative 5 on our y-axis. Our slope is negative 1, so down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Oof, we're getting a lot of points on here. Go back to our y-intercept and reverse it. Up 1 to the left 1, up 1 to the left 1, up 1 to the left 1. So we're creating that line with a nice, consistent negative slope. We're graphing a solid line, so no need to worry about picking up my pen. Okay, I'm going to make sure I label it. I've got arrows. Okay. And shading. Like I said, it's greater than. Where are my y values greater in relation to the line? Well, they're up here. So I'm thinking I'm going to shade up. I can still use the origin as a test point, so might as well. Because that origin is above the line, I'm hoping it's going to work out that it should be a solution. So we'll get 0 is greater than or equal to negative 0 minus 5. No such thing as negative 0. 0 is greater than or equal to negative 5. That is true. It is a solution, so we are going to shade above. One of the things I like to do when graphing an inequality is I go to do the shading of my second inequality. I like to just kind of change the angle of my shading a little bit. This way you get a nice cross hatching. So I'm just going to kind of change that angle. And notice I'm extending through the entire coordinate plane. I'm not stopping where that other line of our inequality is. Ooh, I missed an arrow. Good thing I looked. I'm extending it through. This way I can see what's a solution to y is greater than negative x minus 5 versus what's a solution to the system. So the last thing we're going to do is identify the solution to the system, and that's where our shading overlaps. So what I like to do is I take my pen, my pencil, and I kind of draw just a big capital S all in there to state the solution. Okay, and you must do this. You must identify the solution area by putting a big capital S. And I like to, kind of show it going through the whole area. On pages 40 and 41 today for your classwork, I really want you to take the time, take the opportunity to practice as we're going towards our test for Friday of taking those inequalities, putting them in slope-intercept form, identifying the y-intercept, the slope, and really making sure you have that process of graphing correct. Okay, so just a reminder, Friday we have our graphing linear equations and inequalities test. The review sheet is available on Google Classroom. That will be due tomorrow at 9 p.m. And the answer key and answer videos will be available tomorrow, as well as our daily ed puzzle lesson. Today's math jokes for mathy folks might be my favorite one we've shared so far. It's, why wasn't the math teacher at school? Because she sprained her ankle. I love that one. Thank you, Harrison, for sharing. Hope everyone has a great day.